One day you get your calculator.
Excuse me. So when we're talking about inverses, I know you guys have all worked inverses in the past. It's not that big of a deal. If you have something where it was y equals 2x minus 1, yeah, and if you had to do the inverse of that, what would you do?
Switch the y.
You'd switch the y and the x, and then what?
Oh.
And that's all it is. So it's x plus 1 all divided by 2 is y. Those two are inverses of one another. Do you agree? Do you think that anything is going to change when we're talking about logs? No. Nothing's going to change. So what happens when we get into the logarithm style of an inverse, it'll look like this. Log base 3 of x is, let me do it the right way, how they have it set up, of y is x.
So switch
So if we go to find the inverse of that, set that up. If I go to get the inverse of that, I switch my x's and y's, and I rewrite it. Now the rule is, excuse me. Choking on a carrot from like 5 minutes ago.
That always happens to me.
Remember that one time? I remember I was thinking when I started watching the video.
Excuse me. Okay. Sorry. Let me restart this here. Your book actually starts the problem with it equaling y, not equaling x. I remembered that after I started choking. All right, so it's no big deal. You can fix that real fast. So when you have something like this, you just got to rewrite. You flip-flop your x's and y's and use the log rules. You're going to find out this is super easy. And then to resolve, it's just 3 to the x. Y. What's up?
Quick question. So if it starts out equaling y on all of them, are we supposed to change them to begin with so that it's equaling x and then change it back?
Because what's happening is,
Or should we just leave it equaling y?
you could leave it equaling the y because that's, when you flip it around, because when you go from the equaling y, when you flip them to x, when you go to rewrite up the x and y and resolve for y, to get y by itself, it's 3 to the x is y.
Okay.
All right? In all honesty, you should be able to go from this step to that step.
Don't you just kind of
So the undo.
That's all you're doing.
like take the 3x and move it
Yeah.
upwards? That's fine.
The inverse stuff of these, yeah, it's the same idea. If it's log of 1/2 of x is y
So then it's 1/2 to the x.
equals y. That's it.
Oh, that's so.
It is really, really easy because your next step would be to switch x's and y.
Hold on, hold on.
And then the rule of logs is 1/2 to the x is y.
Osmosis.
It's the mostest.
I was
Okay.
really
Yes, sir.
surprised.
Let X and Y be the same number
No, because you're
They're
finding
not-
the inverse.
Yeah, you're not, the x and y values.
And that carrot.
Wouldn't it be 1/2 y equals x?
Excuse me.
No, because
What was that?
Why wouldn't it be 1/2 y equals x? I missed the first minute and a half and I'm so lost.
Flip-flop x and y.
Yes.
The rule of the logarithm is 1/2 to the x is y.
Okay.
That's all it is. Once you flip-flop x and y, you're just using your exponent. You're writing it in exponential form. That's it. You just rewrite it through. It's that fast. Okay?
Wait, so like,
So our homework number 60 was like,
Number 60?
So numbers, oh, yeah.
Number 60, you have log base 7 of 49 to the x. Now in this one, you could simplify it. You would simplify it first. Okay? Here, so y equals 2x, and now when you flip-flop them around, x equals 2y, so it's 1/2 x. That's a trick question on that one, because you can simplify the log prior to going.
so the log like doesn't really matter.
No, because you can simplify it. Yes, ma'am?
So like, I know a log u x.
Yes.
I'm making
Now, when it comes, like I said, when it comes to graphing, though, the graphing is where we're going to take a little bit more time to go through some stuff, because you actually have to. Okay. I know, it's tough.
Wait, can you let me write down?
Yeah. It's okay. So let's go ahead and start looking at graphing here. It's still the same section. And when we're working through graphing, it's kind of a real nice rules that they use for graphs on logs. You don't need a calculator. I won't let you use a calculator, so you can just go ahead and forget about that. But all graphs, we'll come back to the E stuff here in a little while, have the following characteristics, if you will. Okay? Notice you have log base b of the quantity x minus h, all plus k. So we have an h and a k again. What's nice with logs, though, logarithms, you do not need to graph a parent function. In logarithms, you only need to give me 2 ordered pairs. And we have to create the ordered pairs by using properties. Okay? Each log equation will have a vertical asymptote. It will always have a vertical asymptote at x equals h. Your domain is always going to be x is greater than h. Your range is always all real. Okay? The graphs themselves are both kind of going towards the right because you're bounded by your vertical asymptotes. You're always going to be moving towards the right. It's a matter of, are they moving up and right or down and right? The way that you can tell if they're moving up to the right or down to the right, if the b value is greater than 1, it's moving up to the right. If the b value is between 0 and 1, it's moving down to the right. Okay? Does that make sense? That's the only 2 way the graphs are going to go. And it's shown by the value of b, whatever your base is. Okay. Nope. All right. So now when we go through these, yes, ma'am. What? No.
Wait,
So-
so can you can never have a negative b?
Correct.
Like,
You never-
is that just for grabbing or?
No, you won't have a negative base.
Okay.
You can't have a negative base in the log. Hmm? I always feel smart when I get like 2 questions right on Jeopardy.
You know what show makes me feel really smart? Family Feud. Because I always get the ones that they don't.
I love Wheel of
Always so much
Fortune.
fun.
I
I
love
hate Wheel of
Wheel of Fortune, it's always a big.
I can
big
watch
problem.
it like
All right.
I have the Wii version of it. Free play on the Wii.
You know what that's called? It's called Hangman.
Okay, it's
So let's look at this graph. We're not using graph paper because that's silly. Y equals 1/2, or excuse me, y equals log, oops, sorry, base 1/3 of x minus 1. So in this problem here, what we have is a base of 1/3. What's my h value?
1.
Ah,
Zero.
0.
Oh, I didn't even
X is 0, K is -1.
Because there's no parentheses. Your h value, this is a nice trick, and that's why I picked this one first. Your h value will always be within parentheses. Since there is no parentheses, there is no h. Your k value is
Wait,
minus
so
1.
the virtual asymptote
I
is
was
H.
right.
Yes. So my h value here is 0. My k value is -1. We okay with that?
Sure.
Now, that means that I have a vertical asymptote at x equals 0, and my domain is x is greater than 0. My range is all real. I do too. I like doing that right off the bat. Get it out of the way. It's done. You're ready to go. Now, here's the trick when you're going to graph these. We know that your b value is 1/3, which means it's going to be going down and to the right. So what I'm going to do is put a little sketch next to that so I know which way the curve is going to go. So when I start picking my values for x, if they don't match up, something's going wrong. Okay? So here's what we use. When we're working with logarithms and we're trying to pick out ordered pairs, we're going to pick ordered pairs that make sense. And I'm sure most of you are going, well, how am I going to do a logarithm in my head? Now I'm going to say, well, it's really not that bad. So there's our asymptote. So x, x equals 0.
Yes.
All right, everything's going to be moving towards the right. And we have two properties in logs. You have a property of log base b of 1 is 0, and log base b of b is 1, which means I am going to pick values of x in this case that will give me 0 and 1 when I substitute in.
No, we only need 2 points.
Correct.
Yeah.
Then that's all it is. What I'm doing here is I'm going to pick ordered pairs. I'm going to pick a value of x that'll simplify my logarithm to the properties here. Because log base 1/3 of 1 is equal to what? 0. So that means what value of x am I choosing? 1. I want the x value to equal 1.
Wait, so then for the other one, like the log base b of b, would that mean that for x it's going to be 1/3?
Exactly right.
Wait, isn't it log b of y equals x? So wouldn't it be 0 over dx?
These are the two properties I'm looking at.
Yes.
These have nothing to do with this.
So,
These are the properties.
so if you're.
Log base b of 1 is 0. b to the 0 is 1. 1/3 to the 0 power is 1. 1/3, log base 1/3 of 1/3 is 1. 1/3 to the 1 power is 1/3.
So wouldn't you want to use 0 and not 1?
You're using the reciprocal property. You're showing that how it shows through. I'm picking the value of x to make this a, this is my x, this is going to be my y.
1 and 1/3.
I'm simplifying my log. Okay? I'm simplifying the log. Here's what happens. If I choose log base 1/3 and I choose an x value of 1, and then I subtract 1 to that, I have to do this part first. Do you agree?
Yeah.
So my x coordinate that I'm choosing for my ordered pair is 1. When I simplify this out, what do you get? This part becomes 0, but 0 minus 1. You don't need to.
Yeah, I know.
Okay? I am simplifying this first log. Log base 1/3 of 1 is 0. Yes, ma'am?
So then the next one, since for your x, you're picking 1/3,
Correct.
so your ordered pair is going to be 1/3 and 0, right?
Very good.
Wait, hold on.
That's exactly.
Okay, now I need to write this other way.
Listen to what's going on.
No.
What you're doing is you're simplifying the log portion first. You want to make the log portion equal to 0. You want to make the log portion equal to 1. Then you tack on your k value. Yes, ma'am?
So whenever we're doing stuff like this, we always just, we choose the base as x for 1, and then we choose x as 1. Is it 1? But the majority.
Sometimes. Because what happens if there's an h value? then you have to play with numbers a little bit.
Okay, so
Okay.
you want to make in the parentheses equal, oh,
You want that chunk of the log to equal 1 or 0. So if there's an h tacked on, you'll have to mess with the numerical. I'm going to go to that one next. Okay. So here we have two sets of ordered pairs. I have an ordered pair at 1 and -1. And I have an ordered pair at 1/3 and 0. Do those two ordered pairs match to the rough sketch that I know the graph is going to go?
yes.
Yeah, connect the dots.
I thought X had to be greater than
Oh, just kidding. I know. I put it on.
Because my curve is moving down towards the right. And that's what it's going to look like. Okay. It's weird because it's not something you're accustomed to seeing. It just takes a little bit of getting used to. Okay.
So we only need 2.
All you need is 2 points. I can make you get a third, it's just going to be awful.
We know our
Yeah,
X.
let's talk
Yeah.
about that.
There's no reason to go more than 2 points because it starts to get really, really, really bad. Because if your next value would be a cube root, so you want to get a perfect cube. So what's the next perfect cube?
Honestly,
8.
we're asking for it.
What's that?
We're legally asking for it. Your
Yeah.
graph is like on the test.
Yeah. Okay. And that's where you go into. All right?
I don't know where that.
Let's do another one.
Wait, I have a question.
Yes, ma'am.
Is there a horizontal asymptote?
No, there is not. Your domain, or excuse me, your range is going to be all real on
So
logs.
it's just gonna keep going. Right.
There's a vertical asymptote because logs generally stand straight up. Tree.
Like actual
Like a
log.
tree.
I get it.
I know. When they're, sorry. Bad humor, McGee. All right, so here we go. Y equals log base 5 of the quantity x plus 2. Now, you have to wear glasses, well, protective eyewear if you're going to try to do that. In this case, what is my base?
5.
My base is 5.
I did it.
My h value is
-2.
-2. Is there a k value?
No.
Okay. So my h value is -2, which means my vertical asymptote is at x equals -2, which means my domain is going to be x is greater than -2. Make sure you put that in there. And my range is all real. We're knocking that all done.
Why?
My domain is greater than 1, so it's moving up to the right. So I'm going to put a little hook in there. So I know that my ordered pairs should match that drawing. If not, fix it. Okay? Start your graphs by throwing in your asymptote.
So, yeah.
We should do x equals -1.
Or, yeah,
Very good. My asymptote goes in at x equals -2. There's my asymptote. Ordered pairs. I want to create my log that have 1 and a 5.
Okay, so what about your
The x values, what do you mean? I want to have log base 5 of 1. I want to have log base 5 of 5. So how do I create a 1 in that parenthesis? I use -1. And then how do I make it a 5? How do I turn log base 5 into a 5? How do I turn the parentheses into 3? So the two x values we choose will be at -1 and 3. Is that? Yes, when it's in parentheses like that, you're taking that piece. You want to make that the same as the base. No, the k is just after you, just like I did a little while ago with that -1. I took care of the log stuff first and then I moved it. Okay. Yes, sir.
So to find the vertical asymptote, you have to have x equals h.
Yes, sir.
So x is x and h is -2.
Right.
Alright.
Okay? So now, again, our two ordered pairs, we want to make this log base 5 of -1 plus 2. That gives me log base 5 of 1, which is 0. So the ordered pair is at -1 and 0.
And -1 plus 2 equals 1.
Okay, that's how I get that first one. After that, I used it with log base 5 of 5. So my x value is 3. Good.
So then your y is. Oh, I forgot about that little thing.
When you do that, you're going to get what for your y value then? What's log base 5 of 5? 1.
And I'm 1.
So your ordered pair here is 3.
0.
This is really getting annoying that this is not registering that I'm writing on this.
I commanded these things because my boy has to work all year.
Ms. Jordan?
Yeah.
Yeah.
Why isn't she asking anybody for help to fix it?
He does. He came in like Friday and he's like, yeah, it's all better, but it's still not working.
Okay. What direction is this moving then? Does it match our idea?
Does it?
It's a great song. Makes you feel like.
Sure it is. Okay.
This repeated
Are you not recycling?
I was trying.
Reusing?
I didn't.
Refilling? What is this? You don't like
refill it twice this
You
morning.
don't like the You want to club the baby seal? No! Not go clubbing with the baby
I'm not
seal.
gonna hit the baby seal. The baby seal's fine because you know what I'm gonna do? Someone else is gonna use it. Okay.
Allie, you need a lot.
There's a little polar bear. It's just clinging to life on a little disc of ice.
Okay.
And its cubs are floating away and being eaten by
No, that's not happening.
It is. It's
No,
happening
not.
right now.
Because if they're floating
You know what?
away, that means the orca isn't eating them. Because the orca's gonna grab them. Stop! Okay, I do that when I yell. But if the orca is eating them, then it's gonna go underwater with them or like take them somewhere. They're not gonna
So-
love the orca's touch. I got you.
But in other words, they're still dead.
Okay, well they're not dead because I recycled. I was only a bad person for like 2 minutes. I'm not even.
You're probably the same person that when they have like the Gatorade, you know how the Gatorade's come to the build.
No, I cut it. I cut it.
So birds don't die.
Yeah. We kill the birds.
I just get too.
Some penguins being strangled. I don't know. I don't know. That does not happen.
Those little penguins are dying.
We can move it to like here.
Excuse me. Yes, sir.
Is the only way that K affects it is finding their line and going next?
It doesn't, yeah. What happens with the K value, you're not, like I said earlier, you're not doing a parent and a shift to this. You're still solving this first portion to match these rules, and then you just add 1 or subtract.
Yes, that's its only effect. Alright.
Take a minute or two. Try this one. What you're trying to do is when you're getting your properties, you want this portion to be equal to 1 and 1/2. You move the other stuff later because you're doing your order of operations.
It's just the exponents.
Yeah, you're just using you're trying to do your order of ops. Parentheses tells you to go there first, and then you simplify it out. So obviously we have a b 1/2, h of 2, k of 1. So my asymptote is at x equals 2. My domain is x is greater than 2. My range is all real.
I did that too.
I also know that it is at 1/2. So am I going up or down?
Down.
That's what I got.
So I gotta do this, okay?
It can't be me.
It's not gonna be 20 to the left ever, no.
No, but it can't be ever be me.
No, we won't have negative bases in logs. That's one of the rules. So from here, it's just a matter of plotting out stuff. Vertical asymptote's at 2. Okay. From now, we want to pick our ordered pairs. I want to create the parentheses to make it equal to 1. So I choose my x value, it's got to be at 3.
Yes.
You okay with that? So if my x value is at 3, I get log base 1/2 of 1. 1 plus 1 is? 2. So my first order pair is at 3 and 2. Think of your order of operations. You want to get this stuff in parentheses equal to 1.
Right. So I did that. I got what they used to it.
Okay. All right, so you have, oh, here's what happened. You thought it was just 3-1. Well, you have 3-1, but you're, did I? Oh, it's supposed to be 3-1. I was looking at it too. I'm sorry, it is at 3-1. You're right, you're right. I'm sorry. It is 3-1. I apologize. I'm sorry. I was ahead of myself. You're okay. I apologize. Please forgive myself. All right. The next one, you want to make your ordered pair or your stuff in parentheses equal to 1/2. So yeah, you're using 2.5. Okay. So your ordered pair there will be at 2.5. So log base 1/2 is 1/2 is 1. 1 plus 1 is. So now here at 2.5, we're up here at 2. And is it matching the idea of it's going down that way? And there's your pair. Okay? And that's how it looks.
You said that like twice.
Oh, let's see if I can make this more difficult.
This is all we're learning today?
Yeah, this was way too much to do in one day. That's why I did.
Wait, so we're not having a quiz on this week?
Probably not. Because today we're going to tomorrow we'll start with the log rules and expanding and condensing. That's where it gets messy, shall we say. One more and I'll give you some props.
Next
Yeah.
week.
It's not,
Valentine's Day Valentine's Day is on Saturday. I don't care what. I don't make it because I don't
it's a sad. I mean,
So at x equals -1 for your vertical asymptote. Ordered pairwise, we know your b value is 3, so is this moving up to the right or down to the right?
Up to the right, up to the left.
Okay, gotta be going that way. Now you're gonna pick ordered pairs that make sense. You want to get 1 inside the parentheses, so x has gotta be 0. So if you have log base 3 of 1, you get 0. 0 minus 3 is?
-3.
Good, so your first ordered pair is at?
0, -3.
Good. Next ordered pairs, you want to get log base b, log base 3, you want it to equal 3, so what's your x value going to be?
2.
2, so log base 3 of 3 is?
1.
1 minus 3 is?
-2.
What was it? 2? Yeah. And it matches our idea of our curve, and away you go. Okay? All right, so I'm going to have you guys do a couple, this time officially do the inverses instead of what you did yesterday.
Are we going to do the same inverse that we were assigned yesterday?
Yes.
What? All right. 56 to 6.
No, we'll change it, we'll change it.
57. Oh, you're going to make it odds?
Yes, this is 491, same section. And then 65 to 75 odds for the graphs. Because all the evens are natural logs, and I don't think we're going to worry about graphing natural log. We don't need to do that. We'll just do the logarithms. Okay? So I gave you 2 inverses and then 4 graphs. Shouldn't take you very long. Yes, ma'am? You don't need graph paper. I'm not worried about using graph paper. You don't have that. All you're just picking 2 points. That's all you're doing. Okay. Do you want graph paper? I'll give you graph paper if you want. No, seriously, if you feel like the graph paper makes you happy. So dandy. Why can't you use it? Yes.
And after he got
Here you are.